Assignment 4.3 might seem intimidating, but you have some strategies that you could use to make these questions more understandable. So use the skills that you've been practicing to make sense of these problems. So one thing that you know how to do is you know how to look at a table of values and how to plot those values on a graph to see if it's a linear relationship with a slope. And you can also look at a graph and approximate where is the y-intercept going to be. And the y-intercept is often going to be useful in solving these questions, answering these questions. Another thing you know how to do is to calculate slope. And you've practiced how to do it two ways. You can either look at a graph and calculate rise over run, or you can use the slope formula and calculate the horizontal change and the vertical change and express that as a fraction. Now, this slide is about choosing convenient numbers. So if you look at these numbers, 37.5, 72.5, 145, 105, some people get a little bit nervous when they see decimals, and that's okay. But remember, if it's a linear relationship that has a constant, consistent slope, it doesn't matter which 2 points you choose when you're calculating slope. So you can choose to use the points that do not have tenths or hundredths, decimal numbers behind the integer. So choose convenient numbers. Another thing you can do that we mentioned before is you actually know how to calculate slope in different ways. So one way you know how to calculate slope is to look at a graph and calculate vertical change or rise over run. So you can do rise over run and calculate slope that way. You can also use the slope formula, and you could subtract a y value minus the other y value, and then the x value minus the other x value. And that's what's done here. 145 minus 105, that's the vertical change. And then 58 minus 42, that's the horizontal change, which simplifies to a slope of 5 over 2, or 2.5. You also know a third way to find out what slope is, in that you can type this equation into Desmos, but instead of the equal sign, you use the tilde, and then you put the ones behind the x and the y, and then you'll get, there will be a little indicator down at the bottom of the screen in Desmos that will tell you what the slope is. So if you put this equation in Desmos after you had this table in Desmos, it would tell you that the slope is 2.5. So you can use this equation to find out what the slope is as well. But please know how to do all three ways. Don't rely on technology. Use technology as a tool, but know how to calculate it with your own brain and your own two hands as well, and your eyes. All right, so you have three scenarios in this assignment. There's one where a guy, Dylan, is selling pretzels. And in your input column is the number of pretzels he's selling. This can be thought of as input, or your independent variable, or your x-axis. And there's the amount of money he earns. So if you think about these as points, the number of pretzels he sells is here, and the money he earns is here. So the x is the number of pretzels he's selling, and the y is the amount of money he brought in when he sold those pretzels. Now, if you want to see if this is consistent each time, there's a couple different things you can do. You could calculate the slope, right? Like here, we calculated the slope and got 5 over 2. You could also, if slope sometimes confuses you, you could just use division, right? You can do 37.5 over 15. And what that tells you is that when he makes $37.5, $37.50, he sells 15 pretzels. And if you simplify this, if you do that division, and you'll get 2.5, but what that means is 2.5 is 2.5 over 1. So what that means is when he sells one pretzel, he makes $2.50. So your dollar amount is on top and your number of pretzels is in the denominator on the bottom. And you can see, if you do this math, you'll see that that's the same no matter how much money he made and how many pretzels he sold. It always comes out to the same constant selling price of $2.50. So think about what we just were saying about slope. What does slope mean in this pretzel selling situation? Now here's a situation about going to the fair. You have to pay two things. You pay an entrance fee, and you're going to need to find out how much is the entrance fee. That's one of the goals. Find out how much that fee is. And you're also going to find out how much it is for a ticket to go on a ride. And I think that in this situation, it's a good idea to graph it. So we need to find the entrance fee and how much does it cost for each ride. If you graph this, the x-axis is your number of ride tickets. I'm just going to put ticks for ride tickets. And the y-axis is the dollar amount that you're paying. So if you go on 0 rides, right here, 0 rides, go up to where your line is. If you go on 0 rides, what does the 6 mean in this situation? 0 rides is 6 something. I'll let you figure that out right here, 6, where the line crosses the y-axis. If you look here, this is for 2 rides. It's somewhere between $7 and $8, about $7.50 approximately, right? So 2, I don't know if it's exactly $7.50, you decide, but it looks like 2 tickets is very close to $7.50. If you go on 4 rides, it's $9. So think about, what does that y-intercept mean, and what can you figure out about the entrance fee and the price of ride tickets? And then you'll also be able to answer the question. Once you think about this, you'll have a good idea of what does the slope mean in this situation. So if you calculate rise over run, what does that number mean? You could also calculate rise over run using any 2 points in the table. What does the slope mean in this situation? And here's the third situation. There is a guy named Darren, and it's his job to drain a tank at the end of the fair. And the manager gives him this information. After 15 minutes, because 1/4 hour is 15 minutes. So after 15 minutes, there is 169 gallons in the tank. After 30 minutes, half an hour, there's 163 gallons in the tank. After 45 minutes, which is 3/4 of an hour, there's 157 gallons left in the tank. And after 1 hour, so 60 minutes, there's 151 gallons left in the tank. The way I would approach this is I would think, I wonder how much was in the tank at time 0. So what I would look, I see that it goes 60, 45, 30, 15 minutes. At 0 minutes, let's just put 0 here, but in reality, it would be up here, right? If you were doing them in order, but there's no space here. So, well, I'll cram it in, actually. So at 0 hours, we want to know how much would be in the tank. And these are going down by 50. If you start here, we're going down by 1/4 each time. Okay? So then look at here. What's happening here? What's the pattern? This is going up 6. This is going up 6. This is going up 6. So to get here will also be add 6, right? Each time we go down 1/4. So on this side, starting at the bottom, we're going down 1/4. And we're going up 6 if we start at the bottom. So this is going to be, what number would be up here? What's 169 plus 6 more gallons? That's how much is there at time 0, before the tank begins draining at all. That is also going to be your y-intercept. At time 0, this is how much water is in your tank. You can also look at the slope. Now, what we did back here, that's like what we did to calculate slope. If you do rise over run, that's the same as your slope. What does slope mean in this situation? Hopefully these hints help you and these examples help you. If not, talk to a classmate or talk to a math teacher or rewatch this video, look at Desmos and try to figure things out. Good job.